right, so we're going to talk of limit of a function and limit laws part 2. So we're going to start by talking about the limits of polynomials. So if p of x is this polynomial of a sub n, x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 0, then the limit as x approaches c of p of x is p of c. You're just going to take that c and plug it in. So the limit of a polynomial at a specific value is just plugging in that value, okay? So the limits of rational functions, if p of x and p of q are polynomials and q of c does not equal 0, then the limit as x approaches c of p of x, q of x is p of c over q of c. You're just going to plug it in, okay? So when we're talking about limits of polynomials and rational functions, a lot of times you're just going to plug it in. So here's our first limit here. So it says the limit as x approaches -1, x cubed plus 4x squared minus 3 over x squared plus 5. What you're going to do is you're going to take this -1 and plug it in. So I'm going to plug in -1 cubed plus, well, I probably should do it down here. -1 cubed plus 4 times -1 squared minus 3 over -1 squared plus 5. All right, so this is going to give me -1 plus 4 minus 3 over 1 plus 5, which is going to give me 0. Okay, so my limit of this is going to be 0. Okay. Now I'm going to look at the next one. It says the limit as x approaches 1 of x squared plus 1 x minus 2 over x squared minus x. Here I cannot, so if I plug in that -1 there, or I plug in that 1, I'm going to have some issues here. All right. And so the first thing I want to do is I want to simplify this. So go ahead and go limit x approaches 1. This factors into x plus 2, x minus 1 over x times x minus 1. These cancel out. And now I can plug it in because I have x plus 2 over 1. The limit as x approaches 1. Now I can plug that in. So I can plug in 1. I have 1 plus 2 over 1, which is 3. Okay? So that's going to give me that limit there. So now what we're going to talk about is what they call the sandwich theorem. Okay? So the sandwich theorem says that suppose that g of x is less than or equal to f of x, and f of x is less than or equal to h of x. So we have 3 different functions for all x in some open interval containing c, except possibly at c. Suppose the limit as x the limit of x goes to c of g of x is equal to the limit of h of x as x goes to c. They are both equal to L. Well, what that tells me then is the limit of f of x as x goes to c also has to be L. So what we're looking at is so if I have, so let's say h of x is going to be my green marker here, and g of x is going to be my orange marker. What's going to happen is, let's say I have h of x, and it kind of does something here, and it kind of comes back up here. And then I have my g of x, and it's kind of moving around here, and they both come to that one point, and then g of x goes away. So now what we're looking at is if I take an f of x that's kind of in between there, and here's my f of x, and it's kind of in between there, and then it kind of comes here. Well, it's saying that that limit has to be there because it's sandwiching them together, to bring them back together. Okay, so hopefully that visual representation helped. So here we're going to apply the sandwich theorem. So given that 1 minus x squared over 4 is less than or equal to u of x, and u of x is less than or equal to 1 plus x squared over 2 for all x not equal to 0. We want to find the limit of u of x as x goes to 0. So the first thing I'm going to do is I'm going to find the limit of x goes to 0 of 1 minus x squared over 4. I'm actually going to find that. Well, this is a polynomial, so I plug it in. That's going to give me 0 squared over 4, which is 0. 1 minus 0 is 1. So this limit is 1. I'm going to find the limit of my upper bound. Limit as x goes to 0 of 1 plus x squared over 2. Well, I plugged in 0. 0 squared is 0 over 2 is 0. 1 plus 0 is 1. So now I know the limit as x goes to 0 of u of x has to equal 1. Because the bottom value, the function that was smaller than or less than or equal to u of x, approached 1, and the function that was greater than or equal to u of x approached 1, so u of x has to approach 1. Okay, so that's using that sandwich theorem. The last thing here is if I have f of x is less than or equal to g of x for all x in an open interval containing c, except possibly at x equals c, and the limits of f and g both exist at c, then the limit of f of x when x approaches c is going to be less than or equal to the limit of g of x as x approaches c. Okay, so this is kind of looking at that function here. So if I